This is another topic on forced vibration. The topic is vibration isolation. Vibration isolation. That is isolating the body by using some specific material from other body is known as vibration isolation. So here you take a machine. The machine is supported over the uh, foundation. When the vibration is created in the machine, the force generated during the vibration will be transmitted to the foundation, and even it will be transmitted to the it will give discomfort to the operator. So in such cases, if the force transmitted in the machine during vibration is not transmitted to the or restricted to the foundation, then the passenger will not feel the discomfort. Hence, some material like uh, rubber, cork are used in between the foundation and the machine. Hence, the force transmitted to the foundation is reduced, and it gives better comfort to the operator. So that's what in this topic we are going to discuss. In this, now this is a machine. Now this is a machine. So here it is supported by some material, some isolating material. It will have a elasticity. So it has a property of spring, and it will have the damping property. So hence, this is a foundation. Hence it is modeled like this. Hence it is modeled like this. Now the exciting force in the machine is F cos omega t or F sin omega t, whatever it may be. You can take. For example, this machine is a reciprocating machine. The machine is a reciprocating machine like IC engine. Hence, what is the unbalanced force produced due to reciprocating part? That will be equal to m omega squared r cos theta plus cos 2 theta by n. So this is the equation. If you remove this portion, as we discussed, the n value will be generally 4. So if you put this n value, this term will be less, negligible. So hence the equation will be m. So what is m? This is a mass of the reciprocating part. We can take this m naught, mass of the reciprocating part, into omega square into r, radius of the crank, into cos theta. Cos theta, theta can be represented as omega t. Omega t. So this is a way you can represent. This is a way you can represent. Here m omega squared r. So in the place of f naught, we give m naught omega squared r. So this is a force magnitude. So that is created by the reciprocating part. Reciprocating part. So in this case, we have an equation. So now, for example, so here force is F, and the force transmitted to the foundation is, let us take Ft. The amplitude of vibration here it is X, and here it is, let us take, this is Y. Let us take this is Y. Or, okay, so in this case, the force transmitted by the force, applied force, exciting force, is known as transmissibility. That is denoted by the term epsilon. So transmissibility. What is transmissibility? Force transmitted to the foundation divided by exciting force. If it is a reciprocating part, that is m naught omega square r. M naught omega. Even if it is a rotating part, that also m naught omega square r. Already we have discussed in the previous problem. Even it is a reciprocating part, if the second term is not considered, secondary unbalanced force is not considered, then the value will be m naught omega squared r. Hence the transmissibility is equal to ft divided by f naught we can take. So this is a transmissibility that is given by the equation root of one plus 2 psi omega by omega n the whole square divided by root of 1 minus omega by omega m the whole square plus 2 psi omega by omega m the whole square. So this is the equation. By using this, we can find the transmissibility. Similarly, y by x. Y by x also it's a transmissibility, but both will be same. Both will be epsilon only. Ft by f naught. This is force transmissibility. It is called as force transmissibility. This is motion transmissibility. Y by x, that is equal to motion transmissibility. For both, it is denoted by epsilon. That can be calculated using this equation. This is about the vibration isolation and transmissibility. So in this section, let us solve similar to we will solve a problem. Before that, this is a equation for transmissibility. Epsilon. It may be force transmissibility or motion transmissibility. Force transmissibility means in terms of that is Ft by F. Motion transmissibility means it will be y by x. So this is exciting force amplitude. This is the motion transmitted to the foundation. If it is drawn in terms of graph, that is transmissibility in y-axis and omega by omega n in x-axis. If you take, you will get graph like this. So initially, when omega by omega n is equal to 1, the transmissibility will be very high. Transmissibility is very high, and below when omega by omega n is less than 1, the value of transmissibility is reducing. When it is going beyond that also, when it is going omega by omega n going beyond that or beyond 1, that also reduces the transmissibility. At 1, that is resonance. At resonance, the transmissibility is very high. That is one in terms of omega by omega n. Another is in terms of C by Cc, that is psi. That is psi in terms of psi. When the psi value increases, transmissibility decreases. When psi value increases, psi value decreases. So it is inversely proportional. So this relations you have to understand. Now let us discuss one problem. So this is in this problem, a machine has a mass of 100 kg. Machine has a mass of 100 kg. That is, M is given as 100 kg. The machine, and unbalanced reciprocating part mass is 2 kg. So within the machine, there is a reciprocating part. In case of IC engine, what is the reciprocating part? Is a piston. So machine is there. Inside the machine, there is a reciprocating part. That mass is m naught. That is 2 kg. 2 kg. Move through a vertical stroke of 80 millimeter. Stroke is equal to 80 millimeter. What is the relation between the stroke and the radius? Already we have discussed. R is equal to S by 2. So R is equal to 40. That is equal to 0.04 meters, right? With a simple harmonic motion, so mounted machine is mounted on 4 springs. 4 springs symmetrically arranged with respect to the center of the mass, and it has only 1 degree of freedom system. We are discussing about 1 degree freedom system, and can undergo vertical displacement only. It is undergoing vertical displacement only. Neglecting damping. What is the meaning of neglecting damping? Damping is equal to how much? Damping factor is equal to 0. That is the meaning. That is C is equal to 0. C is equal to 0. What is psi? C by Cc. If C is equal to 0, psi also 0. That is the meaning. If damping is neglected, so then psi is equal to 0. Calculate the combined stiffness. Calculate the combined stiffness of the spring in order that the force transmitted to the foundation is that is Ft. force transmitted to the foundation is 1 by 25th of the applied force. 1 by 25th of the applied force, that is F naught. F naught or F, whatever it may be. So that is from this, we can find Ft by F or F naught is equal to 1 by 25. So transmissibility is equal to 1 by 25 when damping is equal to 0. When damping is equal to 0. When the spring motion and the speed of the rotating crank is 1000 RPM. It is rotating at 1000 RPM. N is equal to 1000. N is equal to 1000. Then what is the value of omega? You can find the value of omega. 2 pi n by 60. You can find the omega. That is 104.7. 104.7. So now we have to find the stiffness. What is the equation for transmissibility? Transmissibility epsilon is equal to root of 1 plus 2 psi omega by omega n the whole square divided by root of 1 minus omega by omega n the whole square plus 2 psi omega by omega n the whole square. So this is the equation. It is given that psi is equal to 0. When psi is equal to 0, the transmissibility is equal to 1 by 25. So 1 by 25 is equal to this equation. In this equation, psi is equal to 0. If psi is equal to 0, this term will be 0. Then we have only 1. So in the numerator, we will have only 1. In the denominator, if psi is equal to 0, this term will be 0. We have only this term. We have square as well as root. Then you can remove. Then you will have an equation like this. 1 by 1 minus omega by omega n the whole square. Right? So from this equation, already we have the value of omega. We have the value of omega. In this equation, we can find the value of omega n. Omega n. What's the value of omega n? It is 20.5. It is 20.5 radian per second. What is omega n? We know that omega n is equal to root of k by m. Root of k by m. From this equation, you can find the value of k. What is the value of m? M already 100 kg. M is equal to 100. And what is the value of omega n? Omega n is equal to 20.5. From this, you can find the value of k. That is 40 to 160 Newton per meter. Newton per meter. So first value we have calculated. K we have calculated. So calculate the combined stiffness. Calculate the combined stiffness that we calculated. So that's the first step. What is the second step? When the machine is actually supported on the springs, it is found that the damping reduces the amplitude of the successive free vibration by 25%. The amplitude of successive free vibration by 25%. That is what is the meaning? That is x2 is equal to reduces by 25%. What is the remaining? 75%. That is 0.75 times x2. This is the meaning, right? Damping reduces the amplitude of successive free vibration by 25%. So x2 is equal to 0.75 times x1. From this, x1 by x2 is equal to 1 by 0.75. 1 by 0.75. We know that delta is equal to log x1 by x2. Log x1 by x2. x1 by x2. So this is equal to log 1 by 0.75. That is equal to 2 pi psi divided by root of 1 minus psi square. So from this, you can find the value of psi. Psi is equal to 0.046. So this is the value of psi. What you have to calculate? Find the force transmitted to foundation at 1000 RPM. Force transmitted to foundation by 1000 RPM. Now, what is the equation? Transmissibility is equal to what? Ft by F naught. Already we have calculated the value of F naught, isn't it? F naught is equal to, what is F naught? Since it is a what is a unbalanced force in the reciprocating mass? Unbalanced force in the reciprocating F naught is equal to M naught omega square R. This is the F naught. So this is actually cos omega t, cos theta will come, but we want only force. We don't want in function. We want only force. So what is the value of M naught? M naught is equal to, already it is given in the problem, it is 2 kg. M naught is equal to 2 kg. And R is equal to 0.04. 0.04. So M naught is equal to 2 kg omega square into 0.04. What is the value of omega? Omega already we have calculated. We calculated the omega value. It is 104.7. 104.7. 104.7 the whole square. The whole square. This will give the F naught value. This will give the F naught value. That will be 877 Newton. 877 Newton. So this is equal to transmissibility epsilon is equal to, what is the equation? Equation is 1 plus 2 into psi omega by omega n the whole square divided by root of 1 minus omega by omega n square, again the whole square, plus 2 into psi into omega by omega n the whole square. So this is transmissibility. We substitute in this equation. What is the value of 1? No. Okay. 2 psi. Psi value, what is the value of psi? Psi we have calculated 0.046. 0.046. 0.046. What is the value of omega? This is 104. This is 104.7. What is the value of omega n? Omega n is equal to 20.5. 20.5. 20.5. So here omega n is equal to 20.5. Omega is equal to 104.7. Here also 20.5. 104. We substitute here. And psi is equal to 0.046. If you substitute everything, you will get psi, transmissibility. The transmissibility value you can calculate. That is equal to 0.044. Already we have the value of F naught. Already we have the value of F naught. So from this, Ft, force transmitted, Ft is equal to 0.044 into 877. This will be 38.6 newtons. So if this much amount of force is applied at this particular condition, this much amount of force will be transmitted. This much amount of force will be transmitted to the foundation. Okay, so this is at this condition. So now next condition is the force transmitted to the foundation at resonance. At resonance, right? Force transmitted to the foundation at resonance. What is meant by resonance? At resonance. At resonance means omega by omega n is equal to 1. So that is a resonance. So in this equation, if you substitute omega by omega n is equal to 1, what will happen? Here in this equation, transmissibility is equal to root of 1 plus omega by omega n is equal to 1. So 2 into psi square divided by omega by omega n is equal to 1. So this term will be 0. This term will be 0. Here you will get 2 into, here you will get 2 into psi the whole square. Omega by omega n is equal to 1. So 2 into psi square. This root, this 2 you can cancel. So in this equation, by substituting the value of psi, you can find the value of transmissibility. What is the value of psi? Psi is equal to 0.046. This is the value of psi. We have the value of 0.046. If you substitute this, you can find the transmissibility. You can find the transmissibility. That is equal to 10.92. So what is the value of Ft? Ft is equal to, already we have the value of F naught. Okay. So in this problem, at resonance, then what is the value of Ft you have to calculate? So before calculating the value, you have to find the F naught value. You have to find the F naught value also. Here we used omega, but here resonance. Here it is resonance. So omega is equal to omega n. So that is resonance. So in this equation, the same equation, instead of omega, you put omega naught. That will give F naught at resonance. F naught at resonance. That is 2 into omega n is equal to how much? 20.5. Instead of 104, you put 20.5. 20.5 square into 0.04. So F naught will be 33.6. 33.6 newtons. Here, if we calculate the Ft, 10.92 into 33.6 newtons. How much it is? It is 367 newtons. 367 newtons. So finally, you have to calculate the amplitude of free vibration. Amplitude of free vibration. So to calculate the amplitude of free vibration, amplitude, we know amplitude x is equal to F by K. F by K. Here, if you find the value of F by K, here, if you put Ft, if you put Ft by K, so that will give the maximum deflection. That will give the amplitude of forced vibration. That will give. So what is the value of Ft? If you put Ft, that is 367 divided by K. So K value already we have calculated. We have calculated the value of K. K is equal to 4 to 160. 4 to 160. 4 to 160. If you calculate, it will give the value of X. Actually, here this is not X, it is Y. It is Y. Displacement Y is equal to 8.7 millimeters. 8.7 millimeters. So here we have calculated force transmitted to the foundation at resonance and amplitude of vibration at the resonance. And this is force transmitted at the particular case. So this is a way you can solve this problem.